But take your infrared sensor, and you got 2 resistors and a capacitor, and put that right into your input. And we have the code on the next slide.
I believe.
No, we don't. Okay, go back. Okay, and Pic Axe has several different statements to get your infrared code in, but it'll take care of that for you. The newer parts actually have a IRN, which is neat because compared to the old parts, I know you don't know this, but the old parts had a different statement, and it would sit there and wait for an infrared command all day. With the new command, you can actually say, well, wait for half a second, if nothing shows up, go on and do something else, which is pretty cool. That's how we're getting the license point right now. Go on to the next one. Okay, now this is your H-bridge driver, your L293. Of course, you can drop 298 in there and you won't copy. And on this particular part, we only have one pulse width modulation driver, so we can only modulate in one direction. If we had 2, we could put one on each side and get it modulated speed going both directions. Or you could build the robot with 2 motors and have modulated speed on both sides and make smooth turns instead of having to make point turns. The way it is here, if you're using a smaller chip, you're going to have to be doing point turns because you've only got the modulation on one motor. But you can see we're starting out slow and going with pretty small back. We'll do that tomorrow. And then pulse width modulation doesn't take much of anything in Pic Axe basics. Go ahead and give us the next slide. Oh, no, we didn't go on that one either. Okay. Go back where you were. Okay. And even the IDE, the program that you use to write the software with, has a calculator in it that can calculate out, I want this to run at 80% duty cycle. Well, it can calculate out what the statement has to be, and even has a button where you can just paste it right into the file. And it's pretty neat. Okay, go ahead and give us the next one. Now this here is a Robinson chip, ULN 2003, and you can use that to run your stepper motor. That circuit before that we had is what they used to run a bipolar. This is for a unipolar. And stepper code is really easy. And it just depends on how much of a pause. Go ahead and give us the next slide. How big of a pause you put in between your statements for your sending a new step, how fast it's going to turn. This is your pause statement for Pic Axe basics, which basically you just tell it how many milliseconds to sit and wait on it. And another nice feature of Pic Axe basics is the toggle statement. You don't have to know the statement. You don't have to look it up. Just tell it to change it. Give it a toggle and it'll change it for you. Which if you're as bad about keeping track of what's going on as I am, handy. Let's see here. We'll put some power on so we're not going to get any action. Nah, I'm good. Just got too many things on this one spring. There we go. Alrighty then. Go ahead and give us the next. Okay, this is how you go about hooking up a servo motor. Well, most servos are fun with the left springs, do an arm drain. Straighten the arm out so you can grab the beard and get it down the bridge. Anyway, that's very simple. We'll just run clip 330 home, and let's see. We can go through this. Yeah. See, all your servo commands are just built right in to Pic Axe basics. The top there is turning on the servo, and this is just telling what position to move to. So, not really all that complicated. But servos do draw power all the time. They're hooked up, so I'm trying to save my batteries. Go ahead and give us another slide. Okay, this is the temperature sensor that we used on the data logger for the balloon. I went ahead and picked this because it goes just a little bit colder than some of the other sensors on the market. And also it turns out to be lucky because Pic Axe Basic has a statement that will read this without any overhead, any monkey motion. It's a Dallas semiconductor one wire, the 18B20. Go ahead and give us the next slide if you would. All you need is this read jump statement up here at the top, and it will bring it right in for you. No software to write, you know. It's easy on a dumb old fellow like me. What the Dallas sensor will actually bring in a 12-bit value. This will go ahead and shave off the correlation going to get bits for you and make it into an 8-bit value. Now, if you need those extra 4 bits, there's a read temp 12 command, which will give you the whole 12 bits, and you can modify them to suit yourself. Let's see, go ahead and give us the next one. Okay, yeah, this is a relay circuit. This is what we were using to try and cut the balloon down, or would have tried to cut the balloon down, assuming you could go up. This is subject for a different day. But basically you're just running. Now of course this is all British, so we got weird part numbers. This right here should read 3904, but yeah, it doesn't. Don't worry about it. This is all you need to do to run a relay. Even you know, you folks that are big into Arduino, you ought to go to the website and download the interfacing circuits section of the manual. There's a lot of good, I mean, all of this stuff I've been showing you is straight out of there. You know, how to hook up different parts. I mean, I'm sure y'all are a whole lot smarter than I am. You got all this stuff in your head. But me, I need stuff somewhere to go and check and see how to do stuff. And this is a real good reference. And even if you never touched a Pic Axe chip in your life, it might be worthwhile having around just a reference, because, you know, a pen is a pen. It don't matter what it's coming off of. Now, your main advantage of the Pic Axe over the Arduino, code's a little bit simpler to write, and it's a lot cheaper, because, you know, even an Arduino, you know, the little Arduino, $12, and the most expensive, the 40X2 that was down there in the corner. Can you run back to that slide? It's running about $9 nowadays. Now, with the Arduino, you got an external oscillator and all of the nice parts. And if you need those, that's great. But all those times when you don't need them, you're buying them anyway. This, you can buy a cheaper part. If you need to add the other parts on, you can. If you don't need to, that's okay too. Like the 8 amp up there in the corner is right about $4. Which, to me, makes a whole lot more sense than spending a whole lot on Arduino and having to reuse it and all that. You can stick one of these in a project and forget about it. Well, I think that's about all I've got. I hope I didn't annoy you too much.
Did you want to show the live program? Do you have the IDE on your screen, on your computer?
The who?
Do you have the IDE?
Oh, yeah. Go ahead.
I don't know where I'm supposed to go.
Pull up the programming editor.
Okay.
Mike will tell you where to go. He knows what he's doing. I'm just...
Hold on, I got it.